So in last class, we had discussed about an linked list. At first, we have seen about what is the purpose of linked list and what is the difference between the arrays and linked list. And then we have seen how to create a node. By using a structure, we have created a node. And today's session, we will discuss about types of linked list, followed by how can we implement a single linked list in a C language. Okay. So now in types of linked list, the first one is a single linked list. So as usual, we people know that we have a node. In a node, we have two fields. One is called an data field, and other one is called an pointer field. Where data field stores the data, and where pointer field stores the next node address. Next node address. So as usual, you can see here, always the head node will have the first node address. The first node address, that's 1,000. For example, the first node address is 1,000. So this is the first node. In the first node, I have a data called 7, and then in the pointer field, I have an address of an next node. So the address of a next node might be 2000. So then the corresponding this node address is 2000. The data might be 5, and then in the pointer field, I'll be having the next node address. That is something called 3000. And then here this node address is 3000, and then here I have a data, and then followed by, and this might be a last node. In our example, this is the last node. So here I'll be having a null. This is a single linked list. In a single linked list, where it will be unidirectional, only one way of direction. So head followed by a first node, and then followed by a second node, and third node or fourth node, and then you can go maximum. But it will not come back. It will not come back. So now here, what is the constraint over here? Suppose if you want to search the data called 5, then can we go and search the data 5 directly? No, it's not possible. So we have to travel through the first node 7, and then followed by we have to travel through to the second node called data called 5. This is a constraint in the linked list. Whereas in the array, we can search the element in an array. But whereas here, we have to process the data by node node by node. Okay, so that's a single linked list. And then next one is double linked list. In double linked list, it's same as single linked list, but here we have one more pointer called previous. Here one more pointer called previous. So now here we can see, as usual, the head. The head will show the first node address. So this first node address will be stored in the head. Then here in the node, we can observe that there are one more pointer is there. That is called previous and then next. The both are pointers, and the center one is alone a data. So whereas in single linked list, we have two fields. One is data, another one is called pointer. Where pointer will point to the next node address. Where in the double linked list, we have a two-way communication, bidirectional. Where single linked list is unidirectional. Where here it's a bidirectional. You can go front and come back. So now here in a node, we have three fields. One is called data, another one is called previous, and then next. This is a fields which we have in a node in the double linked list. So now head pointer will always points to the first node. Head pointer will always show the first node address. Okay, that's a head pointer over here. So here in the next node, I'll be storing the next node address. Next node address. But in the previous, since it is a first node, the previous will be null. The previous will be null. So now here, the next node we can observe that in the previous field, I'll be storing the previous node address, and then in the next field, I'll be storing the next node address in the next field, and then here in the third node, okay, it stores the previous node address over here, and then the next is, since it is the last node, it stores a null. It stores a null. So now I will show you one example. So head is 1000. Head is 1000. So in the first node, in the previous field, since it is the first node, the previous field will be null. And then we have a data, that is something called 05. And then the next node might be the address of something called an and 2000. This is the first node. This is the first node value. So now the next node, second node. So in the second node, you can observe that the previous is pointing towards the first node. Previous is pointing towards the first node. So what's the first node address over here? The 1000. 1000 is the first node address. So in the second node, previous field, I will store the address of the first node, and then in the data field, I will store some value, and then in the next field, I will store the next node address. The last node in our example, third node, the previous node addresses 2000, and data might be, you can store any value. And next node, since it is the last node, I will store the value here as a null. Okay, so this is an example for an and double linked list. Double linked list. So the double linked list is bidirectional. So here we can travel towards the front and we can come back. We can access both the ways of data over here. This is called double linked list. Our next type is circular linked list. Circular linked list. It's same as single linked list. The only difference is in the single linked list, the last node will be having a null. The last node will be having the null. So instead of having a null over here, it will be giving back to the first node itself. It will store the first node address. So you can observe over here the circular linked list. The head pointer is 1001. The first node address 1001. So here we can see 10 is the data and 1004 is the address of an next node address. And then the 1004, 15 is the data, and then 1008 is the next node address. In 1008 node, 22 is the data, 1012 is next node address, and then 1012, 50 is the data, and then usually in a single linked list, in place of here, we'll be having a null. We'll be having a null. Since it is circular linked list, it will goes back to the head node itself, first node itself. So what's first node address over here? 1001. So it has been given as a 1001. So the link has been created from the last node to the first node to form a circular linked list. Okay. And next one is double circular linked list. Double circular linked list. So now it is an advanced version of an double linked list. So whereas here in the previous we have a null over here, the last node next will be having the null. Okay, since it is a one way of direction. So in the previous is an null and the last node next is a null. In the double circular linked list, in the first node previous will stores the address of the last node. You can see here the first node address is 100, second node address is 200, and third node address is 300. So now here, usually in the double linked list, what we'll do, the previous will be null, and then data, and then next node address is 200. And then here in the second node, the previous node address is 100, and next node address is 300. And then here we'll be having the previous node address 200, and the next node will be having null in double linked list. Since it is a double circular linked list, so the last node next will point towards the first node. So here you can see here I have stored 100 over here in the last node. Like same wise, the first node previous will point towards the last node. So you can see here 300. Okay, this is the types of an linked list. In types of linked list, we have seen about a single linked list, and double linked list, circular linked list, and double circular linked list. Okay.